So how's everybody feeling? First of all, I mean, we're like, last couple of hours. We got like two more talks left. Everybody awake? Did everybody just eat like 5 cheeseburgers? I actually avoided it because it's kind of a bad move if you get ready to give a talk like this. And yeah, I also had like, I ate all of the lamb vindaloo at the Indian place last night. So yeah, I've had plenty of meat in the last 24 or even 12 hours. So no hamburgers for me. Um, so yeah, so welcome to an overview of Azure Cosmos DB. Quick show of hands, if you'll indulge me. How many of you have actually used Cosmos DB before? It's a relatively new service, so yeah, couple of you. I've given this talk probably 4 times in the last year, and the first time I gave the talk, nobody raised their hand when I asked that question, and it's get a few more every time. Okay, so a few of you have used Cosmos. How many of you are like MongoDB developers who are like coming to heckle me? Okay, a few more of you. I've actually had several do that in the past. They're usually polite about it, but yeah. Anybody else like using like Cassandra, React, other like NoSQL? How many of you have like never used a NoSQL database before? You're kind of just curious how this stuff works. Okay, cool. Well, we'll talk a little bit about that. I'm not going to spend a ton of time on kind of NoSQL kind of basics, but certainly if you have questions, raise your hand or politely shout them out. And if it's something we can't cover kind of during the 40 minutes, then I'll be happy to stay afterwards. If you see me later, you can buy me a beer and we can talk about it. I'm a I'm a pretty cheap date. Um, My name is Josh. I speak on a lot of things and do a lot of independent consulting with clients around the world. This is not my first time to Sweden. I actually did some work for a client in Stockholm earlier this year in January. Which Stockholm's a lovely city, but in January it was a little rough. But it was really fun. It was a great time, and I had a lot of fun with that client. I'm a Microsoft Azure MVP. I do not work for Microsoft. That's usually something I wanna specify and clarify ahead of time. So I am free and able to talk about not just the good but the bad of things like Cosmos DB, and hopefully you will see that. And again, if you have questions, if you're wondering kind of what the downside is of all this wonderful magic technology, then just ask. And yeah, if you want to find me on MySpace and those kinds of things, that's usually where you can find me. Okay, so let's start. So Cosmos DB started actually in 2010. So the core of the technology has been in existence for almost well, not quite a decade, but close. It started as a research project at Microsoft's research arm, Microsoft Research, and the story goes, I won't go into the whole thing, but the basic story is that, of course, Microsoft is this huge organization. They have services like their like Bing, which is their Google competitor, and they have Office 365, and they have Xbox online games, and they have all these they're these big online services that have to service millions of users every day around the world. And so several of these teams were sort of having the same general problem, which is how do we scale data so that we can do it around the world and have relatively low latency with replication and not essentially not have to solve this problem n number of times for n number of teams and projects that are again all trying to solve the same basic problem. So, long story short, they formed a team. They did some research. They kind of got some interesting ideas together. It had enough momentum that they formed a team. They spent a couple years building some stuff, and around I think it was 2013 or 14, they started using the precursor to all this technology internally. And 2015, I think it was, they released the first kind of public version of this called DocumentDB, which was a document-oriented NoSQL database service, and that became available on Azure. So some of you may have seen that within the last couple of years. And that was, kind of one kind of narrow version or flavor of what became the full-featured product and was released earlier this year, which is Cosmos DB, which is what we'll talk about talking about here now. It is a managed NoSQL database as a service, and that's kind of a big mouthful, but what that basically means is, we can just break it down. It's a NoSQL database, so this is not SQL Server, this is not Oracle, this is not MySQL. It is JSON data under the covers. It can be document-oriented. There are actually multiple data models, and we'll talk about those a little bit later, but there's a document-oriented model, there's a graph-oriented model. It's the same core data and kind of inner workings, but the data projections on the outside that you see as a consumer can actually vary quite a bit depending upon which one you're interested in using. It's also a managed service, so you can't install this on your own hardware. You basically use the Azure portal, or you use APIs, and you create an account, you create databases within that account, you create collections, and you add and read and write data, that sort of thing. But it's all managed for you, so you're not patching VMs, and you're not specifying how big the VM should be and how big the cluster should be. All of that elasticity is kind of managed by the infrastructure, the core infrastructure that's behind the scenes, and that by and large that's a good thing, and we'll explain more why. It offers one of its most compelling features. It has a number of them that I think are really differentiators. But one of the biggest ones is this notion of not only geo-replication, which is a hard enough problem, but it's actually literally at this point it's push-button geo-replication. I'll show you a bit of this in a later demo. But the idea is, there are 40+ Azure data centers around the world, and you can just click with a couple of button clicks, you can set up your data to be replicated in any number of them around the world, and that's something that think about it. Was it Arthur C. Clarke, right? The sufficiently advanced technology is indistinguishable from magic, right? So think 5 or 10 years ago, how difficult it was, and in many cases, some cases, impossible to set up replication. It was possible, but it was very difficult, even replication even between two data centers 5, 10 years ago. Now, if we had a few extra minutes, a 40-minute talk, if I had a few extra minutes, I could actually set up replication to half a dozen data centers all over the world while we're just sitting here in this room from my browser. It's not magic, but it certainly looks like magic if you kind of jumped from the past into the future, from 5 years ago. Another big feature that it has is this notion of low latency reads and writes. And when we're talking low latency, what we're talking about are milliseconds. Typically, the upper bound, the SLA upper bound, I believe are 10 millisecond reads and 15 millisecond writes. Milliseconds. The actual kind of real world statistics, if you talk to some of the folks on the team, they actually see median values of 5 or 6 millisecond reads and sub 10 millisecond writes. So really, really fast. Just blazingly fast reads and writes. And that's happening within the same data center. If you use your laptop and your 56K modem and you're on a boat somewhere, you're not going to see the data getting from the data center to your laptop in 10 milliseconds. There's obviously latency there for the connection between you and the data center. But if the code that's accessing the data, if that's all co-located in the same Azure data center, then that's where you see those kinds of latencies. All of this is backed, and I'll be talking more about this as we go, but all of this is backed with 4.9's SLA. And in order to make that, which is obviously a great SLA, it's also backed by monetary guarantees. So if they don't meet the SLAs, you actually have very easy statistics that you can use to prove, hey, you guys didn't meet the SLAs, and there's monetary compensation involved with that. All of this happens because you as a consumer of Cosmos DB, and this is sort of one of the things you kind of have to get used to and understand when you adopt this and use the service. You actually have to, when you decide you're going to use Cosmos, you have to understand what your intended usage patterns are going to be, and essentially how much throughput you're going to need. So if you think about, if any of you are familiar with things like Azure Functions or AWS Lambda, those kinds of serverless compute kind of functionality, those things tend to be you pay for what you eat, basically. So you just kind of use it, and if you use 10 seconds over the course of a month, then you just pay kind of time slice, and it's a couple of it's a very small incremental number. That's not the way that Cosmos DB works, precisely because the only realistic way to get to a 4.9's SLA, which is one of their kind of core differentiators of the service. The only way to realistically get to that is if the Cosmos DB team and the people that run that infrastructure, if they understand kind of in aggregate all the people that are trying to use the service, how much throughput do they all need kind of in aggregate? There's no way to sort of make a good guess and then at the same time offer this 4 nines SLA, because I could say, I'm just going to use it a little bit. I've got 10 users, and then all of a sudden, my new social media app spikes through the roof, and I have 3 million users. It goes viral, and it's not possible for me to go back later and say, no, but you didn't meet this 4 nines SLA if they have no understanding of what my anticipated usage is going to be. So we'll talk a little bit more about this notion of provision throughput, but it is one of the core things you have to understand when you adopt the service. Is there are tools that can help you, and every operation reads and writes in the service has a kind of a normalized notion of cost, and there are tools that can help you figure these things out, so you're not like totally off in the woods on your own. But there is something that's some responsibility that's put back on you as a developer, certainly, to understand, okay, well, my application is going to be doing 80% reads, and most of them look like this, and we'll be pulling down data that's maybe 3K in size on average. And you can do a little bit of math, and there's some calculators that can help you online, and then you can kind of spit out a number and get some sense of what your throughput is. But that's part of the entry fee, if you will. Real quickly, and then I'll get to a demo. There are no schemas here. So again, this is not a relational database. You're not specifying ahead of time, this is kind of what my data is going to look like. These are the columns, data types, all that. You're not doing all of that. And that's, generally speaking, that's a good thing. If you're, those of you who put your hand up and said you were Mongo developers, this is very similar to something like Mongo. You don't have to do that sort of thing in Mongo. You don't have to do that sort of thing here. The nice thing is, again, one of these other nice features you get, one of the other ways you get to these really low latency reads is that everything's auto-indexed. All the properties essentially in your JSON, all of the kind of leaf nodes, if you will, are all indexed by default. You can kind of play around with that if you know that you're never going to index into or you're never going to query into a certain subset of your documents. You can tell Cosmos DB, don't index this. But by default, even inclusive of all the performance guarantees and scalability, that sort of thing, it does auto-indexing under the covers for you. There are a number of language SDKs, so certainly .NET, it's a Microsoft service, so of course .NET has a full-featured SDK, but there are also others, so I'm going to forget one, because I always do, but Ruby, Python, Node.js, PHP. There's rumors of one for Go. I don't actually know if it's out there yet, but there's supposedly that one is maybe at least being thought about or maybe even being worked on at this point. And the other nice thing is that all these SDKs just sit on top of a core REST API for the service. So everything, anything you can do in the service, whether it's kind of administrative kind of stuff or reads and writes and CRUD and that kind of thing, all queries, all of it can be done using the raw REST APIs. And so if you have any platform that can talk REST, you're good. You don't have to wait around for an SDK. There are also multiple data models. I talked a little bit about that a moment ago. I have a few other slides, so we'll talk about that in a second. All right, so let's enough hand waving and that sort of thing, and let's look at a little bit of code. I am a developer by trade. Let me switch to my virtual machine. I'm a developer by trade, and I'm kind of old, so I first learned to write code in school using C and C++. But I've done a lot of .NET development and C# development for a long time. So the demo that I've got here is in C#, but all of this can be done again using lots of different languages. And if you really wanted to, you could do all of this using REST as well. So just kind of bear all that in mind. Standard disclaimer. All right. So basically, what we're going to do is I've got a Cosmos DB account already provisioned. That usually takes a few minutes. But I'm going to create what I'm going to do is I'm going to create a new collection, and then we're just going to dump a little bit of data, just a handful of small documents into that collection, and I'll show you what that looks like. And then we're going to do a couple of different queries. There's a few different query styles or patterns or options, if you will, certainly from .NET and from others as well. And we'll just kind of walk through real quick what that looks like. This is the code, but before we do that, let's switch over to my browser. And I'm in the Azure portal here, and I've kind of already navigated to my Azure Cosmos DB account. If I zoom in here and get the magnifier window out of the way, then this is my account, Josh-Øredev already. So I've already pre-provisioned that. But what I want to do is I want to create a new collection. So I click on Add Collection. And first thing I have to do, of course, is give it a name. So I think in my code I called it, or refer to it as Hello World. So I'll do that. Is this, let me zoom in a little bit, just so this is, that better? Good? Okay. Yeah, we'll call this Hello World. You have a few different options. If you're kind of doing something modest, you can kind of start with a kind of a fixed upper bound for capacity. If you know you're ready to create the next Facebook, then you can just use the unlimited storage option. There's a little bit of differences in capability, but the cost is the same, at least initially. Here's where I specify how much throughput I need. Throughput is expressed in terms of this kind of abstract unit called a request unit. And that sounds kind of weird and scary, but basically what a request unit is it's an abstraction over a measurement over top of the amount of basically the amount of CPU, RAM, network I/O, disk I/O, like the infrastructure that's needed to, in this case, for one request unit corresponds to all that infrastructure capacity, resource capacity needed to read a single 1 kilobyte JSON document from the service. Every operation, whether it's a read or a write, no matter how much data you're pushing back and forth, every operation has a normalized cost. So if I do a query or if I do a write to the service, when I get a response back, no matter what happens, I get a response back, part of that response will include how much that just cost me. So I can actually use that to sort of, save those statistics, and I can use that to figure out over time, do I need to adjust my throughput? You can, when you pick this to begin with, you can adjust it at any time you want to. So you can adjust it up and down. But so, when you initially start, you're going to be guessing a little bit, and that's okay. That happens to everybody. There's some calculators. I won't show the calculators, but there's some ways you can like paste some JSON into a browser and answer a few other questions, and it'll give you like its best guess of how many request units you need to provision. But it's usually just a guess, and you have to play with it a little. But just know, again, that's just part of the process. I'll stick with a 1,000 request units here just to start with. I'm also not going to use partitioning. Any of you, I guess it's raining. Any of you who are familiar with distributed systems and that sort of thing, you're probably familiar with the notion of using partitioning as a scalability strategy. Cosmos DB uses it extensively under the hood. For the most part, you don't have to interact with it. You don't have to care. But the one way that you do care is if you know you want to partition based upon some key. The idea is that you typically want, if you're going to use partitions, you want them to be uniform relative to the types of queries you know you're going to be kind of issuing to the service. So it's maybe you have data that kind of breaks down by country in the EU or something like that. Then you might use, if you have a country property somewhere in your JSON, then you would specify the path here to that country property, and that's the key essentially that Cosmos would use to kind of physically divide up the data so that it's it scales well and queries are fast. In this case, I won't even specify a partition key. I don't need one. My database, I already have a database in here called default. I could create a new one if I wanted to. You can create as many as you want. They're just logical named buckets. I'll just use the one that's already there, default. Just takes a second to create these. I say that, yeah, okay, it's created. So I've got a new collection created called Hello World. I'm gonna go back to my code. This VM's a little slow, so, all right. So I've got some configuration here already. Those of you familiar with .NET know that you can specify configuration in XML. And so I'm already referencing my database default. Hello World is my collection. I've got some other connection information in here. So that should be good to go. So I'm going to start this up, and we'll step through the code a bit at a time. Step through the code a bit at a time. Here we go. All right. So read my configuration information so that we can connect. And I won't go through like the details necessarily of the .NET SDK. Let me zoom in here a little bit. Because again, if you're using Node and you're not a .NET developer, then you don't really care that much, and that's okay. It doesn't want to zoom, and I don't have my mouse. That's okay. Can everybody read that sort of well? Yeah, okay. All right, so anyway, I create a new document client, which is kind of my, my object that I use to connect. Give it my connection information. and specify a URI to my collection that I'm going to write to. So I've got this collection of objects in memory here, which are just movie objects. And these are just a handful of my favorite movies. For each movie, there's a title, there's the year it was created, and then a list, an array of actors that appear in the movie. And I'm just going to write these. These are just objects. I'm just going to serialize them to JSON, and I'm going to write them to Cosmos. So we'll just iterate over each movie. Call create document async. It's an asynchronous operation. I'll wait on it because I don't have anything else to do. So I'm just going to wait for each of them to be written. And yeah. Boy, this is awful slow. All right, let's run down to this next line. All right. So at this point, we should have some data in there. So if I go back to my browser and go to the Data Explorer and go to my Hello World collection and the Documents node, then yeah, this is a little tough to see in the browser. There are better tools to do this, but this is easy. So this is my first document. It artificially created yeah, that's a little difficult to read. Let me zoom. Artificially, Cosmos created an ID for me, which is just a 128-bit GUID because it needs something unique to identify the document. If you specify one yourself, you're free to do that. I didn't, so it created one for me. So yeah, so here's my title, the year, the actors, and then some additional metadata that's unimportant for our purposes at this point. So that's the first one. You could see that there were 5 total in there. So nothing up my sleeve. You know, data was written to the database. So let's go back to the code. All right. So now we want to do a couple of queries real quickly. First thing we want to do, how many of you are .NET developers? Okay, so you know, okay, most of you, cool. Okay, cool. So you know link and all that kind of thing. So there is in the .NET SDK, there is link support. It's not quite as full featured as like Entity Framework if you're used to that. So a few of the link methods haven't been implemented fully for Cosmos yet, but most of the basic ones you want are there. But you can see this is a basic query that we're going to do. We're going to say query the movies collection and show me all of the movies, give me all of the movies where Alec Guinness appears as one of the actors in the movie. So there are actually 2, as I recall, from this collection. Should be Star Wars and I can't remember which other one. Let's look. I'm writing the titles to the console, so this is easy enough. Yeah, Star Wars and Lawrence of Arabia, which is a little tough to read, but yeah. So we got some data back from Cosmos. So that's kind of in .NET. That's kind of the link-oriented syntax for doing queries. So if you're familiar with and comfortable with Entity Framework, then again, not everything isn't quite there yet in link, but a lot of it's there, and you'll be pretty comfortable right away, kind of just using the link syntax if you want. But you have other options. So Cosmos also supports what I'll call a flavor of SQL. So if you look, and again, let me just see if I just zoom in. Yeah, if we look at this SQL that's here, this is certainly not, if you're familiar with something like SQL Server, this is not transact SQL. It's not PLSQL if you're familiar with Oracle. But if you squint a little bit, it's very similar to other SQL dialects. So select star from, in this case, I'm just injecting the collection name dynamically. Alias it as C, where array contains is just a function that Cosmos supports that allows you to kind of dig into a nested array and look for elements inside the array. And so I just want to match the actors array. I want to look for Bill Murray in this case. So everybody kind of gets the idea of what's happening here. The point of the SQL support in Cosmos is not to be like one-to-one perfectly matching ANSI SQL. I'm told actually by the team has talked publicly and said that it would actually be possible for them to fully support ANSI SQL. They just haven't done it yet. I think it's one of those things that if they get more customer feedback, then they might prioritize it. But the point isn't to be fully compliant. The point is to allow developers and folks who are familiar with SQL to be productive with a little bit of a few tweaks here or there. So we've got our SQL query. So now we're going to issue another query against the same collection, just using a slightly different style. In this case, just specifying the SQL query this way. And so in this case, I think there's only one movie, that Bill Murray appears in, which is Ghostbusters. So yeah, Okay, so that's it. Bless you. So that's it. Just a real quick introduction to the .NET SDK, how you write data into the collection, and then how you can read it back out a few different ways. And there are, I've shown you a couple different ways. There are probably 50 other, possible ways to do similar things. Just know that this is just a very quick intro to that. All right, so let's get back into some slides, which would help if I got out of my VM. Here we are. All right. All right. So Cosmos is cool. One of the things I really like and appreciate about it, and I'm biased because I'm a developer by trade, but Cosmos, because it's a managed service and because of various other reasons, the need for a traditional database administrator and IT folks getting involved is pretty minimal. I can spin up, as a developer, I can create an account, I can create databases, I can create collections, I can administer security. There are a number of things I can do just kind of through the Azure portal, through management API calls, et cetera. Like, I don't need to wait 6 weeks for a DBA to decide that person is going to help me accomplish some of those things, which is certainly more traditional with something like an on-premises database. So there are a number of things inside of Cosmos that are like particularly nice and helpful for developers, which I want to point out here. There are stored procedures, triggers, and UDFs, and you write them in JavaScript, which is really interesting. So basically, Cosmos embeds inside of the runtime. Cosmos embeds a JavaScript runtime, and it runs in proc with all of the other kind of infrastructure for Cosmos. So I won't do a demo of it just in the interest of time, but it's very straightforward. The documentation is really good. But if you want to write stored procedures, essentially do like kind of big long logic and kind of bury it and run it inside the database proper, as opposed to kind of making multiple calls back and forth. That's kind of the typical reason you would do it, is to avoid having to make big long network hops back and forth from a server to the database. If you have like a lot of work you're kind of chaining together. Stored procedures in Cosmos will allow you to accomplish that. There are things like triggers. So as you insert and update data, you can fire off of that and do other things. UDFs, typical stuff that we're kind of used to if you've done any database work. Your boss likes this one, and it's obviously at this point in time, this is not a nice to have. This is essentially necessary. But you can't talk to the service using any of the SDKs or REST API unless you're using SSL. So by default, you've got an encryption there, and then all of the data is encrypted on disk when it's at rest. And that's not at this point. I don't even think you can change that. I think at one point there was a flag you had to set to opt into that, but I think they've changed that. So now it just is always encrypted. So again, even when you've got those like 5 millisecond reads and 10 millisecond writes and all the auto indexing behavior and all that in the 4 nines SLA, that's all inclusive of whatever cost is associated with doing the encryption on disk as well, which is pretty cool. This is a semi-random list curated for things that I find particularly interesting. Your mileage may vary a little bit. There's a change feed infrastructure for Cosmos. So this is sort of like triggers for Cosmos, but you can essentially trigger and interact. You can handle the events essentially, insert and update events, handle those anywhere inside of Azure or even outside of Azure. If anybody's familiar with the new, it's kind of in preview, the Azure Event Grid service, which essentially lets you. It's like a huge distributed event bus infrastructure in Azure that basically everything in Azure, no matter what you do, I mean, quite literally, it's still being built, but eventually will fire events through this event grid infrastructure. And Cosmos DB it'll have the same sort of mechanism where you'll be able to, somebody adds new documents or updates documents in Cosmos, you'll be able to handle that. Every time that happens, you can handle that in an Azure function. You can handle that in AWS Lambda. You can write something else to another database somewhere, send an email. The world is your oyster as far as that goes. But that's a pretty interesting mechanism in and of itself. There's support for geospatial data types, both storing them and then querying them and updating them, that kind of thing. Not everybody needs that, but if you do, just know that it's there. There's a local development emulator. So of course this is a managed service. It all runs in the cloud. Yay, that's awesome until you get on an airplane or you're on a boat or you just don't want to pay. You know, your Wi-Fi goes down in your house, whatever, and you want to do some work locally on your laptop. There's an emulator you can download which is API compatible. It is a development emulator. It's not intended to be like offline mode or using it in production to do production things. They're pretty clear about that. But it will. I think there are actually there are a couple of cases where the functionality isn't quite the same just because it doesn't make sense. I mean, the Cosmos has certain functionality which works quite well in a distributed managed service environment, and it doesn't always translate directly to your laptop. But for the most part, basic CRUD operations and basic things will work the same. Yeah, so serverless function binding and triggers. This is a little bit similar to what I was talking about earlier with the kind of event grid infrastructure. But basically, if you're familiar with things like Azure Functions, Azure Functions has full support for triggers and bindings to Cosmos, which is really handy. So you can do things like the output of an Azure function can, and in fact, I'll show an example of this. An output of an Azure function can just be an object, and that object, once you set up the binding, that object can sort of like magically be written into Cosmos, as a new document into Cosmos DB collection somewhere. So you don't even have to, all the code I showed you earlier, where you like set up the connection and you have the connection string, and then you issue a query or you do an update. You don't even have to do all that. You can just set up the binding. It's a little bit of configuration, and then return an object from your Azure function, and then that object will just get magically serialized and dumped into Cosmos, which is pretty cool. All right. Let's see how we're doing on time. Okay, we don't have much time left, so let's go quick. All right, so there's a document-based API that's like very similar to Mongo. We've talked about that already. There is actually MongoDB compatibility. If I have time, I'll show this real quick, an example of this. But if you're using Mongo today, by and large, you can take an existing application, change a connection string, and it will just start working. There are some caveats there, as you might imagine. They're still working on the final version of this. But there are actually some cases of some pretty significant applications where quite literally no code had to change. It was just a connection string change, and you go, 1 minute you're talking to Mongo, the next minute you're talking to a Cosmos DB instance, which is really cool. And if you think about it, it kind of makes sense, right? Like Microsoft wants everybody to start using this thing. So what's like a big pool of developers who they can kind of attract to the service who might already be familiar with NoSQL, and that's Mongo developers. So they do a pretty good job of keeping up with that sort of thing. This is a little bit niche, but if you happen to be using Azure Table Storage, one of the oldest services in Azure, there's API compatibility now for that to talk to Cosmos as well. So again, if you have an app that uses table storage and you want to just point it at Cosmos, change a connection string, don't change code, then you can get that as well, which is pretty cool. This one's pretty interesting. So Gremlin is a kind of an open source quasi-standard API for doing graph queries, graph-oriented queries. So nodes and edges between nodes. Graph databases are, depending upon what year it is, they're all the rage, and they're very interesting for a certain set of problems. So there is API-based support or API-level support in Cosmos for doing these kinds of queries as well. In fact, I think I have an example of this. Something I did is, Stack Overflow. I don't know if you know, but Stack Overflow makes their data, all their like user data and question and answer data, public, and you can download it every month. And it's this huge amount of data. It's like hundreds of gigabytes. It's actually really useful for demos if you ever have to need a lot of data and it's something that people can relate to. So I downloaded some and put it and got it into Cosmos. It got into a couple of Cosmos collections, and but I did it as a graph. So essentially created like nodes in my graph for users, questions, answers, and comments. I think it was. And then the connections between them, the edges between those things. So like I as a user, maybe I asked 10 questions, but I also answered 20 questions, and so I have all that stuff represented in a graph. And I just took a subset. I didn't take all the users, but you can do these kinds of questions pretty easily. So these are the kinds of things that if you have that same data in a relational database, it's not always very easy to ask these kinds of questions, but they tend to be very natural in a graph style. So yeah, of the Stack Overflow users who have provided more than 50 answers, so like the super users, how many questions have they themselves asked? And so again, that's something that maybe is a little challenging with a relational database, but in Gremlin and in Cosmos, it's actually quite straightforward. So we want to look for users, so nodes or vertices where the label is user, where the user answer count, so essentially the edges that are the outbound edges from those nodes, where the count of those is greater than 50. And we want to do a projection, so basically a select something, like if we were using SQL. But in this case, we just want to, again, we want to count up a different set of edges. Instead of the answers, we want to count up the questions that those users who have answered the more than 50 questions, we want to count up the number of questions that they have asked. So that's kind of what that looks like. And if we, if we had a Gremlin console, we were talking to Cosmos, we can just spit that out and we get a kind of a nice little flat list of users and the questions that they had, number of questions that they asked. So again, that's kind of the basic style. There's a bunch of really good documentation for doing this kind of thing and some good examples for doing this in Cosmos. Okay, so real quick, let me show the MongoDB support, since we do have a few Mongo folks here, and this is actually pretty interesting. So, okay, so I downloaded a Mongo Shell. Those of you who do Mongo know that there's no like built-in GUI, so like there's like 10 million of them, right? And most of them go away after 6 months. But this one hasn't gone away yet. It's called Studio 3T. I think it used to be called Robo Mongo or something. I don't know. Anyway, so what I want to do is I want to connect to. I've got an existing Cosmos instance, which I'll show you here. I've already created it. And I enabled the API compatibility for Mongo already. I have one collection in here that I've called stuff. I don't think I have anything in here. Is that 5 minutes? Okay. Talk fast. I don't think I have anything in this stuff collection yet. So we'll add a couple of things and then we can go query it using Mongo. Yeah, no documents. All right. So I was going to build the connection from scratch and kind of show you all that, but let's just let's do it the easy way. I've already connected a couple of times, so I'll click on you can trust me that you can build the connection using basically there's like properties in the Azure portal, and you can just translate those into Mongo ease. It's very easy to connect. So if we look up here, we see we've got, come on, zoom. There we go. So I'm connected to this blah 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 .documents.azure.com. So it's Cosmos DB. It's talking to Azure, but it thinks that it's Mongo. So it's protocol level compatible. So this app knows nothing about Azure. If I were running on Linux or a Mac or something, then I could be using some other Mongo shell, and we could do the same thing. So in this case, I've got an admin database, which is kind of standard Mongo stuff, and I've also got this default database, which I've already created. And there's my stuff collection. So if we open this up, nothing in there. So we'll add something just real quick so that we can go verify it's there. So we'll say ID, Josh, age, none of your business. Yeah, that's enough. That's all we need. So we'll say add document. So there's we've added our document. We can see it in our shell. So now let's go back to the browser, and I'll hit refresh. We're still pointing at that collection here. You can see now we've got a document. Now we've got a document. There we go. Yeah, so it gave me Cosmos actually created. Those of you who are Mongo folks know that underscore ID is your ID, right? That's your ID property, and it gave me a unique, just generated an ID for me because I didn't already have one. I called my thing ID, but whatever. And yeah, that's our document. So that's kind of the basic idea. There's a Mongo shell in here. You can run commands. Those of you, one of the things that's kind of in private preview, any of you who are Mongo folks who maybe have tried this before and you tried to do like an aggregation pipeline and it didn't work and you were like, that's like a common thing that everybody does in Mongo. That's actually being worked on right now. They recognize that that's people want that. So it's not quite there yet. I think the team is saying like by the end of the year that maybe that's going to be public, but it's not quite done yet. But stay tuned. All right, let's see if I can do a couple of slides before we're done. And again, if you have questions afterwards, please feel free to come and ask. I'll be happy to talk about it. All right, definitely don't have time to go through all this. Just know that there are multiple consistency models that you can choose from in Cosmos. That's a big fancy way of saying you can have transactional consistency like you're used to in a relational database. You can have eventual consistency like maybe you're used to in like distributed systems where eventually all the nodes in the cluster kind of agree on the state of the world, but maybe it takes a little while. The interesting thing, and this is a relatively unique thing, this is a unique thing for managed database services, is that there are a number of other models you can choose from in Cosmos as well. They're kind of scenario specific, and they don't apply to in like the general case, but they do apply in certain cases. And so it's useful if you're going to use the service and kind of get the most out of it. It's useful for you to read up on these and understand kind of if they apply for your situation. Again, if I had a bit more time, we could go into it a little bit further. Probably don't have a ton of time on this. Just know that, yeah, I talked about replication. This is essentially, how robust and scalable the system is. Does automated backups, which is cool. I talked about the latency. 4.9's SLA we've talked about already. This is the other demo I wanted to do. We're kind of out of time. I wanted to basically do the replication. It's a really simple example of like setting up a collection and then having a single writer that's kind of writing data to one replica, and then having multiple listeners that are listening, we can kind of observe the millisecond latency for essentially the data to travel around the world to other data centers. It's actually a really cool demo, but unfortunately, this is actually a 60-minute talk that I'm trying to condense down to 40 minutes, so something has to give. Real quickly on use cases. Main use cases, they're kind of unsurprisingly, if you've got to deal with geoscale data, not everybody has to, of course, but if you have to, then you frankly have pretty limited options. There are some others, but Cosmos is certainly a really good one. So that's one example. If you have very dynamic schemas, so like maybe you have data, like a good one is like user-generated content or session-oriented content, or like that sort of thing, or maybe users are generating a lot of kind of custom content themselves, and so the structure might vary between users. That's like a typical NoSQL pattern. Cosmos obviously does that very well. IoT is another good example of that, where maybe you have multiple versions of devices out in the field, and so they produce slightly different data depending upon what version you're talking to. Gaming is also a big one. There's a couple of white papers actually on the Cosmos in the Cosmos documentation for some gaming companies that have made really good use of Cosmos. So keep that in mind. It's also still cool to love your relational database. It's not like it's an important point, but it's not like Cosmos is like going to take over the whole universe or the cosmos, and like relational databases are going away. That is not what's happening here. Cosmos is very useful for a number of scenarios. It has a pretty broad set of use cases, but there are other cases where a relational database works quite well, and I would encourage you to kind of not just get rid of that and just chase the new hot thing, even if you find this interesting. There are cases where relational databases are still necessary. I'm like 1 minute over. Can I go like 1 or 2 more minutes? Okay, I don't want to get fired. All right, so what's hard about Cosmos? We talked about this, anticipating throughput needs. Like, how much throughput do I need for my collection? I used the default when I created mine a moment ago. It's hard. I mean, it's not an easy thing, and I will be very upfront with you and say it's not impossible. But what I will tell you is, having worked with a couple of clients and done this a little bit, you will get it wrong the first time. You'll probably get it wrong the second time, but you can adjust it at any time. It's just an API call. You can go into the portal and change it. You can make an API call and change it. You can change it 50 times a day if you want to. If you have a lot of traffic coming at 3 p.m., if you have like one of those like seasonal kind of things, or if traffic spikes at certain times of the day, you can crank up the throughput and get all the data and do all the stuff. And because you're paying for that, of course, the more throughput that you request, you're paying more for it. But then when at 6 p.m. when your data needs have gone back down and all your users have gone home, you can just crank it back down, and then you're paying much less at that point. So, just know that that's out there, and it's something you have to deal with. There's a handful of kind of migration issues if you're kind of a relational person and you're trying to get something working in Cosmos. Just, be aware of some of those things. I can make all these slides available if anybody's interested. Some partitioning nuances, which I sort of talked about. And then the tools are getting there. They're not really awesome yet, but they're getting there. Last slide. So this is like I've worked with Cosmos for a while, and these are just kind of guesses on my part of what may be coming. I expect that there'll be, well, in fact, I kind of know unofficially that there are more and more query APIs coming. There'll be more support for, today there's support for like Mongo compatibility. I happen to know that there will be more coming along the way. I won't say which technologies will be kind of next, but more is coming there. So stay tuned for that. Some of the pricing innovation stuff I actually think is interesting. One thing I mentioned this to kind of everybody I talk to, because eventually somebody's going to build this. I kind of want to build it myself. But the whole notion of like request units and figuring out how much I need and how much throughput I need, that sort of thing. Again, you get all that data. Every request that you make, it will tell you how much that cost you. And so somebody could actually take all that data, dump it into a database, and then put some clever machine learning on top of it, and figure out essentially what you're going to need, like project what you're going to need in the future. I'm kind of hoping that Microsoft will build it, but if they, because it's like one of those things that should be built into the service, but eventually somebody will do it. So. At any rate, yeah, that's all I have. If anybody has any questions, thanks for being here. I hope you had a good week. And yeah, enjoy the rest of the talk, or the rest of the conference.